Hello everyone, welcome back to the channel. Today we are going to explore Java development kit and what JDK is. The JDK is the complete kit of software responsible for creating, compiling, and debugging and executing the Java applications or program. And it's the foundation for Java development by bundling essential tools, including the Java compiler, debugging utilities, and documentation generators. And it also provides complete Java runtime environment, and the Java runtime environment includes JVM inside that, and the JVM is responsible to convert all those bytecodes into native machine code, and the JDK is platform specific, and it must match your operating system, and it this functionality making it the primary choice for software engineers and developers working on the Java projects. So the next thing is Java's runtime environment, and the Java's runtime environment provides everything necessary to execute compiled Java applications on end user system. And what it contains is Java's virtual machine, core class libraries, and supporting runtime components that allow Java programs to run seamlessly. Unlike the JDK, and the JRE excludes development tools such as compilers and debuggers, making it lighter and ideal for users who only need to run Java applications without developing them. So, for example, you are getting the Java code that is compiled by Java C compiler, and you got the bytecodes of that compiled Java code, and then you don't need anything else other than JRE. So JRE provides the complete Java runtime environment to execute the Java program, and this makes JRE the standard choice for application deployment. The next thing is JVM. So JVM is the component of JRE, and the Java Virtual Machine is an abstract computing engine that interprets and executes Java bytecode, serves as the heart of Java write once run anywhere philosophy, and it acts as an intermediary layer between compiled Java code and the underlying operating system, providing platform independence by translating bytecode into machine-specific instructions. And JVM manages critical runtime operations including memory allocation, garbage collection, security verification, and thread management. That thing makes it an essential component present in both JDK and JRE installations. The next thing is just-in-time compiler. So what just-in-time compiler is and what it does is it's an intelligent performance optimization component embedded within the JVM that bridges the gap between interpretation and compilation. So during the program execution, just-in-time monitor code behavior and identifies frequently executed sections known as hotspots, and then dynamically it compiles these critical bytecodes segments into highly optimized native machine code, which executes significantly faster than interpreted bytecode. So this transparent optimization process happens automatically at runtime. It is delivering near native performance without requiring developer intervention. So the key difference between JDK and JRE is JDK is for developers, and it contains compiler and full development suite, and the JRE is for end users, and it's for both actually, developers and end users, and there is no compiler inside JRE, and it's a runtime environment, so it provides the runtime for executing the Java code or converting the bytecodes into native machine code. The component relationship between JVM and just-in-time is so JVM is an execution engine, and it's a part of Java's runtime environment, and it's platform dependent. So JVM is platform dependent, but Java is platform independent. So just-in-time, what is just-in-time? So just-in-time is present inside Java's virtual machine, so it's the component of JVM, and it acts as a performance optimizer, and it's a runtime compiler. So we have seen all the definitions here, so let's move to the next part. So just-in-time, if we see briefly, then we can think of just-in-time like a smart translator who learns shortcuts. Like first time it slowly reads and translates instructions, and it notices repetitions like, hey, I'm doing this again. So then next time it's gets smarter than previously, so it remembers the translation of previously translated codes. So the next time when the just-in-time compiler go to translate the code, it uses saved version of that particular chunk of code instantly. Suppose we have to calculate sum of 1000 times in a loop. So what will be the steps are that without just-in-time compiler, it interprets each loop iteration slowly, and with just-in-time compiler, after few iterations, it converts to fast machine code, and the result will be remaining 990 plus loops run 10 or 100 times faster. So let's see how Java execution process works. So first, in the step 1, we write Java source code in the .java file, and we compile the Java code into bytecode using Java C compiler, and those bytecodes, or you can say .class file, will be compiled by JVM again, and JVM interprets and compile both things JVM done through just-in-time compiler and JVM interpreter. So JVM loads the class file via class loader, and it verifies the bytecodes for security purposes, and then interpreter executes the bytecode line by line, and then next just-in-time compiles hot code into native code, and then CPU executes optimized machine code. So let's see why this architecture matters. Is that it's a platform independent system. So we write the code once and we can run anywhere. So also it includes security through bytecode verification, and performance optimization via just-in-time compilation, and it also provides automatic memory management. So this is the all information about JVM, JDK, and JRE. So I hope you liked the video, and please subscribe for more videos like this. Thank you.